All right.
You have to take it in California.
Yeah.
Thank you. Tuesday. Thank you. Okay. So let's where are you at? Right. So why don't I go through quickly, before I do that, are there any questions on the recorded lecture material from Monday? Oh, so yeah.
On the final.
Yes. So the notion of lists within a list, and we effectively had this table, right? Yeah, that will be on the final. So I do, in fairness, it's a new idea. So I gave you a homework today. We're going to have another in-class problem doing that. And then for homework for Monday, yet another one. So I hope you get the idea of it. But I'm happy to go through an explanation of it if people are confused by what it is and how to use it. Hopefully the homework and the review problem we'll have today will clarify that. But you do need to know it for the final, okay? Do we still find it confusing? So let me just go through another explanation. Okay, so I'm hoping everybody is okay with the notion of a list, right? So you can have a list, 10, 20, 30, right? Stop me if I'm saying stuff that doesn't make sense. So all that we learned was that we did briefly look at that actually. You could have had a list, 10, 20, and then in here you could have had a separate list, right? So a list can consist of individual elements, or it can consist of its own list, or another list. The lists we're interested in really are lists, is a list that consists of a bunch of sublists. So let's take a look at list 3. So list 3 consists of the list, which consists of 1, 2, 3, a second list that consists of 4, 5, 6, and a third list that consists of 7, 8, 9. Okay? So instead of having an individual element like we had a 10 here for list, here the first element of list 3 is a sublist 1, 2, 3. So let's first go through the mechanics of it, and let's then talk about why you might want to have this. So the mechanics of it in terms of defining it is just what I did. The only mechanics in terms of understanding how to use it is if I were to say, let me actually go into Python because it's probably easier to do it this way. I'll just make this list. So if I print out list, it's all of those items. If I were to say list bracket 1, actually let's do bracket 0, what should that print out?
1, 2, 3.
The list, right, it's the list, Katie, it's the first element, which happens to be a list. It's the list 1, 2, 3, right? And if I were to say list 1, it's the second list. It's the third list, right? So accessing the elements, okay, accessing the list, each element is the same as we've learned before. The only new idea now is that since list 1, suppose what you wanted to get at is the second element of the first list. If I were to say list 0, that's going to produce the list 1, 2, 3. But now I can have yet a second index. So this, okay, so this, what does this produce? This produces the list 1, 2, 3, right? If I were to say list, and now I put a 1 there, what should that give me? 2, because it's taking the second element of the first list. So you can almost think of it now as a as like a 2 by 2 table. Not like, it is. This is a 2 by 2 table. What this really is you can think of it this way. It's the list 1, 2, 3. That's the first row. The list 4, 5, 6. That's the second row. And the list 7, 8, 9. And if I wanted to access something, well, this is going to be the 0th row, and this is going to be the first column. This would be the second row, and this would be the second column. And the only mechanics in terms of using it is that it's a little weird, is that when you specify things, you now specify things with 2 coordinates. But it's no different than what you sort of get from the table. You can almost think of it as being like an Excel, where the first value is the row and the second value is the column. We don't have letters. We have it sort of backwards from the way you do it in Excel. Excel, you first specify the column and then the row. But just think from math. You have a grid, a 2 by 2 grid, and that's all there is to it. So that's the mechanics of it.
The mechanics are pretty simple. Just I struggled with the part of actually reading values into a list.
Okay. So let's do that. So here's the homework assignment. So let's go through where we're assigning the values. So size is simply the number of rows. So this is from 0 to 3. So, Panos, one way to create this 2 by 2, this list that consists of list is first create an empty list. I'll call it row. And then here what I'm doing is I'm going through okay, again, this is going to be 3, so I'm going through 3 times, and I'm generating a random number between 0 and 9, and I'm appending it to row. So row initially doesn't have anything in it. I come in here the first time, I generate a random number. Let's suppose I generate 7, so this evaluates to 7, and now I'm going to append 7 to row. So row is a list that has 7. Now, this loop here now, this inner loop here, I'm going to do it again because j is now 0. Now I'm going to make j 1. And now I'm going to come back and generate another random number, right? So suppose I generate the number 5. So now row already has 7 from before. Now I'm going to append 5. So now it's 5 and 7. And then I'll do it a third time. And so now when I exit this 4j loop, row is a list that has 3 values. And then what I'm going to do is I'm going to take row and I'm going to append it to board, which had nothing in it. So now what I'm doing the first time through is adding the first list to board. So now board has 1 list in it. And then I'm going to come back to this 4i loop because this is going to go from 0 to 3. I is now 0, so now I is going to be incremented. I is now 1. I'm going to do this same loop again, initializing row to nothing because I want to build the second list with 3 new random numbers, so I'm going to initialize row to nothing and just dump 3 values in it. And so now so this is going to iterate through for 3 times. Row is going to have 3 values in it. And now when I come out of this for loop, row is another list. Board already had the first list, so now I'm going to append the second list to board, and now I have 2 lists in there. Okay, so this could be confusing. Okay, so I guess a rule of thumb here, or sort of an idea is, note here that we have a 2-dimensional array that has rows and columns, a 2-dimensional grid that has rows and columns. More often than not, if you're dealing with a 2-dimensional, where you have something with rows and columns, you're going to have 2 for loops. An outer one, in this case, is controlling the number of times we're going down the row, and an inner one that's controlling what we're doing for each row. And note, because this for loop, this 4j loop is executed within the 4i loop, it starts from the beginning each time you fall into it. So this outer one is doing it for each row, and now we're building up each of the individual columns, and then we're just going to come around and do it for however many rows we need. So any clearer? I suspect it's clear. You still need more practice with it. But most of the time, if you're dealing with individual elements in a grid, a 2-dimensional grid, more often than not, you're going to have 2 for loops. One that controls going down. It doesn't have to if you're going down from row to row. One that controls which row we're on, and then inner to that is going to be what you're doing within each of the rows. And here we're trying to build up another list of 3, and so we used another for loop. So that's how I initialized the board. Note here, everybody, so I'm jumping around. So I wrote a function to print out the board where I wanted to extract each individual element, all 9 of the elements. So note again, everybody, that I had 2 for loops. I had one for loop from I going from 0 to 3. That's going down the rows. And then notice that this is indented from the I, so this is going to be executed. So this gets executed 3 times, and then for each time this gets executed 3 times, for a total of 9 times. And therefore, I'm going to be going through each element of board, and board is where I dumped all the values in. And note here that I have board, bracket I, bracket j. This is the row, this is the column. Here's the code where I was summing up going down the rows, and you note here that I don't have a 4i and 4j, I just have one for loop because I'm only going through, right, I'm getting the total for a particular row. So here I'm getting the total for a particular row, and I'm now going here board row, so row is actually going to point to whatever row I'm in, and I'm going through each of the columns in row. So J, I have just one for loop. Since I'm not going through the whole board, I'm just going through one row. And in a similar manner, let's compare these two when I'm calculating the column, where I'm passing to it the column that I want to total. Notice again I have one for loop, where here I'm not varying the column. This is the column that I want to add up, whether it be 0, 1, or 2, and I'm varying the row I, and so I have I going from, again, since it's square, I'm always going either across 3 or down 3. But since I'm not doing the whole board, I'm just doing one column here, the column doesn't get varied in the for loop, only the I gets varied in the loop. And for the diagonal, okay, since I want to get coordinates 0, 0, and 1, 1, and 2, 2, well, the diagonal going from the top left to the bottom right, note here that, again, I have one for loop where I is going from 0 to 2, and here I is going to first generate the coordinate 0, 0, and then the next iteration 1, 1, and the next iteration 2, 2. This one, going the other diagonal, is a bit more of a pain in the neck. So here, when I is 0, so this is going to be 0. What I want it to be is 0. So for my diagram, when I'm doing this diagonal, going from the top right down to the bottom left, or either way, so I want to generate the coordinate 2, 0, 1, 1, 0, 2. And so I is going to be 0, so if size is 3, size minus I is 3 minus 1 is 2. When I is 1, so size minus 1 is 2 minus 1 is 1, so then it's going to generate 1, 1. And when I is 2, so size is 3 minus 2 is 1, and minus 1 is 0, so that would generate the coordinate 2, 0. So this was a bit tricky to try to do in a for loop. And for the whole thing, all I did is I assigned the values, which is what we first saw. I had a function which printed the board out. And then I had a for loop going through all the rows. Well, all the for loop was actually just doing it 3 times, and here I'm just adding up all the rows. I'm doing each row individually, each column, and then when I come out of that loop, because there's only one diagonal from left to right and another diagonal from right to left, I call those 2 diagonal functions. Why don't we do the following? Is there anybody who want me to go over any of this again? Yeah.
Can you explain this is going back to the print board function. And this is a concept you went over in the lecture, the end equals thing.
Yeah.
I'm a little confused with that.
Okay, so if I have a program that has 2 print statements, it prints hello and bye, right? No secret here. But one of the things it's doing for you, you might or might not want, is after it, by default, if you have a print statement and don't say anything else, after it prints out what's ever here between the parentheses, and then adds a new line character to say, okay, he's done printing that, I'm going to the next line, so that when we printed by, it was on the next line, right? But let's suppose you didn't want, after you printed hello, to go to the next line. What you can do is say, you know what, after you print the line, don't put a new line character, but instead, in this case, print a space. And so if I run this, you'll notice now it didn't put by on the next line. It printed out hello, printed a space, and because I had the end there and said put a space in there, Python says he doesn't want the default new line character to be printed. And therefore, it kept the print on the same line so that when I executed the by, it appeared on the same line as hello. So if you want to not have the default behavior of printing a blank line, of going to a new line, you can instead put comma and then some character, and that will replace the new line character when it prints out. I could have printed in here instead of that, I could have had XX, and if I ran that, it would have printed out hello. After the hello, it printed out the XX, inhibits the new line character, so it prints by next to it. So all it is a way of, instead of printing the new line character, allowing you to control what gets printed at the end of the print statement. And its most common usage is to keep it on the same line. So you might have a whole bunch of print statements you want on the same line, and the way you can do that is by just adding an and. And you can even have nothing in here, in which case it would print just next to one another. Okay, so it inhibits, I think its biggest usage area is to inhibit going to the new line. But it has this other advantage that if you wanted to put something else in there, okay? So all it is what gets done at the end after the print statement is concluded. You have a pain look, Taylor.
Well, my code for the calculate sum diag 1, it's coming up as an error. It says index error, index is out of range.
Yeah. What does that mean?
And yes.
Okay, so that's good for everybody. Well, not good for Taylor, but for everybody else. We'll learn by our mistakes. If you ever, so when I've defined this list as being 3 by 3, effectively, right? Get that? I can only have an index, so if I'm referencing list 3, the value of the first index can be what values?
0, 1, or 2.
Correct. If you somehow did a calculation and the value you put in there was a 3, it's going to give you an index error. Similarly for the second one. So whenever you get that index error, it means that what you're trying to reference within the list doesn't exist.
But if the range is from 0 to size, technically wouldn't I still be in range?
You know what, you could have, so one problem could have been that you referenced a row before you added it. This is, which function was this in that you got the error?
Calc sum diag 1.
More like, so, you know how you could debug that? So I would go into my code, and I would then say, so suppose it's this code here, and you have some coordinate, or you're doing this one here, diag 2?
Diag 1.
Diag 1. So you have some coordinate. I would print, what I would do is, I would say print, and then print out what the coordinate is. So that'll tell you what the number is, and that'll sort of give you a hint as to where you might have gone wrong. I think I posted this solution on Blackboard. So why don't we do the following? So I handed out 2 sheets. One is the homework that's due for Monday, that's tic-tac-toe. I'll talk about that later. But the other one is an in-class problem. And so, okay, so what I want you to do now, why don't we do this now so we can do it together? Why don't we take 20 minutes to do this? It's not so easy. Everybody should be able to get 1 and 2, 3's harder. So what I want you to do in number 1 is I want you to create a 5 by 5, I'm using the word array, you can think of that as a table or grid, and fill each element of the array with a random number between 0 and 9, and then print out this array with the heading original board. So I actually did this. It's going to go away when I printed. So, okay, so, oh no, I have it on the other side. So on the back of it, it's a sample output. So you're going to print out the word original board, and you're going to print out this 5 by 5 grid. Then, and I say you should use a function. If you don't want to use a function, we can punt on the functions for now. If you want to just do this in main, because the whole point of this is to give you experience with these 2 by 2 grids. Then the second thing that I want you to do is to create a second list or array, which consists of all the rows of the first one, but with the row order reversed. So if you look on the sample output, you're going to see that on the original board, the first row is 62305. If you look on the row switched horizontally, you're going to see that the last row is 62305, and that the second row in original board is 30132, and that's the second to last row in the second grid that you're creating. So you're reversing the rows. You're creating a new list where the rows now are reversed from the original board. Does everybody see that on the sheet of paper? And then if you get that going, well, why don't you guys try doing that first? So you don't have to write functions. I'm going to write it with a function, but so you're going to write something that is going to initialize it to, it's going to be a 5 by 5 board. You're going to initialize the values to random numbers, and then you're going to create a second list that's going to have all the rows of the first one, but with the row order reversed.
Professor,
Yo.
I think you might have posted the answer for homework 21 instead of 22.
I posted, okay, no, I posted this, I'm sorry. I'm going to post the homework. I'll post the homework answer now, right now, sorry.
Thank you.
Don't look at the solution. You do it yourself. You're crazy if you look at the solution. Okay, I posted it. You can copy code out of that if you'd like to take a look at it. Okay. Anybody get it? Oh, good. So let's take a look at some ideas of how we might attack this problem. Let's just do the first thing where, assuming this is our board where we have row 0 has these 5 elements, row 1, these obviously can be random. And since I gave you the code that we did for homework to generate the board, which only did 3 by 3, obviously it's going to work for 5 by 5 if you change the size to 5. So the code to assign the board is the same as what we did, as I showed you for homework. Instead of having a size equal to 3, it's 5. It's just going through this loop twice, as we saw before. But, okay, so assuming that board, let's just assume that board exists, and it consists of 5 lists, each list having 5 elements, and let's just assume this is the data. These could be random. So what we really want to do is we want to now create a new board. Let's call it VBoard. This is called board. And what we want to do is we want to take this last list, we want to make this the first list in VBoard, and we want to take the second to last list in board and make this the second list in VBoard. And so really, if we wrote out, if assuming that there were just 5 rows, then we could execute this code right, where we are taking the 4th row of board and appending it to VBoard, and then appending the 3rd row of board and appending the 2nd row and then the 1st row. So this actually would be the solution to the problem. But I don't like that solution, because if I had 20 rows, instead of having a 5 by 5 table, I had a 20 by 20 table, I'd have to repeat this 20 times. So that seems not like such a good idea. And if you look at the statements here, they're all effectively the same. The only thing that's varying is the row number here. So really what this comes down to is somehow can I create a for loop that first generates a value that has the number 4, and then the number 3, and then the number 2, and the number 1, and that would be the end of it. Agreed? Because these are all the same statements, and this reverses the board. This says take the 4th list in the board and append it to VBoard. So that's making it the first list in board. Take the next to last list in board, board 3, and then append it to board, which would make it the second list in board. And then take this, the 3rd list in board, and append it to VBoard. And so these sequence of steps reverses the list from board, making VBoard just the reverse in terms of row order of board. And this code would work, but I don't want to necessarily write out these. Could I somehow, it seems to me that I'm going to want to have like a 4 and it would seem like I want to do this 5 times, so maybe I could do this 0 to size, where size is equal to 5. Right, so this is going to now iterate through assigning I the values 0 through 4, which is almost what I want. The problem is that the first time through I is going to be 0. I want I to be equal to 4 the first time through. So, well, let me stop here. Does everybody see the method here, what I'm trying to do? So does anybody have any idea how I could fool around with this for loop? What I really want to do is I want I to assume the values of 4 the first time, and then 3, then 2, then 1, then 0. If I don't want to assign I that, I could create another variable that would assign that, but I would at least iterate through 5 times, which is what I wanted to do because there were 5 rows. So how could I now, what code could I add here so that I could generate a number, either the variable I by changing the 4, the values of this around. Anybody have any ideas? Right, I want I to assume, I know I, at this point, I is going to assume the values are 0 to 4, 0 to 4, 5 values. Okay, so if you're, well, there's a couple of things. So I could say, I could create another variable, and I could say, and this, you do this all the time, this is lowercase j. Go through your head what the value of j is going to be through each iteration. So yeah?
Wouldn't it be easier to just make a new list and call it the reverse of board?
Will that work?
That works for me, yeah. And then the code would just be the same as the original print statement, basically, but you're just using it.
So instead of doing this, you would simply say,
So
you say board is vboard is equal to board, and then you do vboard dot reverse.
yeah, I did the colon negative.
Okay. Yes, that would work. It wouldn't give you exercise using a for loop to go through this, but that would work. So that's fine. Sometimes you're not going to be able to, I'm trying to get you to do, sort of give you experience going through using these indexes to go through the individual rows. And so it certainly would work on the exam, but let's go through this solution. So does everybody see why this works? Because when I go through here, when I is equal to 0, if size is equal to 5, so let's just assume here, right? So size is the number of rows. So size is equal to 5 because it's a 5 by 5 grid. So 5 minus 0 is equal to, oh, strike that. It's going to be 5 minus 0 minus 1. It's always the problem. So if size is 5, you subtract I from it is 0, so it's still 5. You subtract 1 from it, it's 4. So j would be 4, and so board of j would give me the last row. When you iterate through again, I is equal to 1, so size is 5 minus I, now I is 1. So 5 minus 1 is 4, minus another 1 is 3. I have to take off this minus 1 because the indexing starts at 0. So now j is going to be equal to 3, which is what I really want. I want to get the second to last row. And you'll see, okay, this is a fairly common idea here in generating a subscript, generating an index where you want to go in the reverse order, where you're taking the last row, subtracting iteratively a number's going from 0 to the size, and you have to take one more off for the index starting at 0. Okay. Let's take, the homework. Hopefully the homework will be more straightforward than this. So here's the deal. Let me go through the homework. And the homework is to play tic-tac-toe. And so So the way this is going to work is as follows. So you're going to write a program that is going to have a tic-tac-toe board, which is 3 by 3, and you're going to prompt the user. This is all in the description here. You're going to prompt the user to enter in a row. So suppose I want, and we'll assume that the rows are going from 0 to 2. So suppose I want to go in cell 1. I'm going to go in row 1, column 1, which is the middle square. And so what you're going to do is you're going to put an X in for my move, or the player's move, which is in the middle. And then the computer is going to make a move, and it went into row 0, column 1. And now you're going to make another move, and so we're going to go in row 2, and I'm going to go in column 0. And so I went in the lower left-hand corner, and the computer went on the second row next to me. And now, let's see if I'm going to win. This is exciting. I'm going to go in row 0. I'm going to go in column 2. Well, I won. It ended the program. I should have said something. We'll run it again here. Let's go in row 1, column 1. I'm going to go I'll go into a different spot. Row 0, column 0. And I'll make some dumb move here. I'm going to go in row 2, column, strike that 1. So it continues to make moves, okay? And at the end of the game, it says who won or lost. Mine did, and then it just exited the program. I don't want to bring it up the code because you'll see the code, and instead I want you to do this for homework. The deal is so that's what you're going to write. Now, you're more than welcome to write this from scratch. That would be a great idea. But if you don't want to write it from scratch, what I have done is I have provided some starter code. So I've actually provided almost all the code. The only thing you really have to write is, let's see what I gave you. Okay. Right. So I've given you almost all the code. I've given you the player move, I've given you the computer move, and the print board. What you have to do is you have to write the function game result. So you're going to take this code, which is in Blackboard, you're going to read it and try to understand it, and then you have to then insert in here the function game result. And I've given you instructions on what game result should do. Game result should return a P if the player won, it should return a C if the computer won, and it should return a D if it's a draw. An A, and then return a blank if it's not a win or a draw, meaning that there's still moves to play. Okay, so you can do one of two things. You can download this and just write the game result function and then play the game and have fun. Or if you want, you could not look at this and try to write the whole game yourself. Or maybe what you want to do, depending on how much time you have, is to try writing the whole game yourself, where my move function is pretty dumb. I'm just generating a random number for my move. I'm generating two random numbers, one for the row and one for the column when the computer has to move. And as long as nobody is there, that's where the computer moves. If somebody's there, it generates two more random numbers. But you can come up with another way of coming up with a move however you like. Mine's a particularly dumb way. I'm not playing a really smart way for the computer. Okay, so this is going to give you more experience dealing with arrays, these two-dimensional arrays, and you can see what I've done. I think it's fine to read this and try to understand it. The game result, you're still going to have to write some code to try to figure out who won. And the homework, everybody, spoiler alert. So the homework you did for today, where you calculated things on the diagonal or going up and down, that actually is going to help you write the game result function, because effectively what you're going to be doing when you're playing this game, oh, that's not going to work. Okay, this is going to bomb. So when you're playing this game, the way I set up the board, okay, so I'm displaying an X and an O for who moved there, but the way this thing is constructed is that the board consists of a 3x3 array. So look at the top, 3 rows, each row having 3 elements. And the value that I'm storing there in the beginning is a 0. So I'm saying if there's a 0 there, it means nobody has moved there. And what I'm doing is that when somebody moves, when the computer moves, I'm putting a -1 in that row and board position, and when the player moves, I'm putting a 1. So as this moves, if I were to move and I said I want to move to this coordinate, then the computer would put in there a 1. If the computer moved here, it would put a -1 in there. So it's constantly updating the board with a 1 or a -1 for the player's move and the computer's move. And so what I'm saying is that if you add things up, so how would you know if I won? Well, if the row totaled to 3, then you'd know I won. If the row totaled to -3, you knew the computer won. So the homework you did for today was adding up rows and adding up columns and adding up diagonals. Here you do want to do the same thing, and you're going to want to see if it's equal to a 3 or a -3, which will tell you either the player won or the computer won. Okay, so that's due for Monday. You could do either just take downloading and starting from there, or try to do the whole thing if you want to be more adventuresome. You need to know how to deal with arrays for the exam, so you need to put some time into this. On Monday, we'll go through this. I won't do anything new, and I'll go through some review, a review problem. No, just go through what's on it. I'll probably give you a review problem for the exam. So, okay, that's it.